So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA GCSE Maths 2022 Higher Paper 3 Statistics and Probability section, and I'll just do a range of past exam questions related to the topics on the revision list. Now, as always, there will be a copy of the set of questions in the description below for you to download and have an attempt at either while watching this video or before watching this video as we go through its answers. Now, before we get started on some questions, let's just review the revision list of the topics that appear on the Paper 3 Statistics and Probability section. Now, I personally believe that you're not going to get a question on every single one of these topics. I think that there'll be a lot of these particular topics merged into certain questions together. So, for example, I reckon that the two-way table question will be linked with independent probability. I believe that the histogram question could be involved in the medians and quartiles and the lower and the interquartile range. Also, that the box plots again are going to be heavily linked with median and quartiles in the interquartile range. And I also believe that the line of best fit and the outlier will all relate to a scatter diagram, even though a scatter diagrams isn't mentioned on this list. So it may be a case of where you're asked to draw a line of best fit or spot an outlier. I think it may even be where if a question says that it's got correlation, do you need to draw a line of best fit, or what direction, what gradient would it be, positive or negative, or things like that would come into play. Now, on the screen, as you can see, what I've done is to try to break down, going through some past example questions, what's kind of going to be included and what you kind of need to revise when reviewing these topics. So with regards to two-way tables, you want to be able to construct a two-way table, and that's going to be heavily linked with ratios, fractions, decimals, percentages, and obviously linked with probabilities. With histograms, you want to be able to know how to construct a histogram from some group frequency data. You also want to be able to read information from a histogram and also work backwards. So in other words, finding the frequency density from a diagram to complete a table, and also finding frequencies. Now, sometimes in a histogram, particularly in some more newer questions, they are linking it to finding the interquartile range and the median and the quartile values or estimated values. So it's worth reviewing and knowing how to do those. When it comes to box plots and the quartiles, again, so you want to be able to work with constructing a box plot diagram. You want to be able to read and compare a box plot or box and whisker diagram, whichever you prefer to call it, and also know how to, when you are comparing, to mention the average, which is looking at the medians, and looking at the spread of data, which is looking at the interquartile ranges. And also, I've seen recently that there are questions regarding criticizing box plots. So sort of noticing when diagrams have been sort of drawn incorrectly, so values in the wrong place, and that kind of links in with commutative frequency diagrams, histograms, scatter diagrams, etc. You then also want to another worth mentioning with regards to mean, quartiles and interquartile ranges, basically working with box plots, work with histograms and comparing. Then moving on to line of best fit and outliers, I strongly believe that this is going to be linked with scatter diagrams. So you want to be able to make sure that you know when to draw a line of best fit, in which you only draw a line of best fit if there is either positive or negative correlation. You never draw a line of best fit if there is no correlation. You also want to be able to know that the line of best fit doesn't always have to go through the origin. And when you are drawing a line of best fit, always try and make sure that it goes through the data set, so either goes off the axes or goes on slightly above. You also may want to look at extrapolation and interpolation as well, to make sure you understand those. So predicting values of when results are going to be accurate, when they're not going to be accurate, and also spotting outliers as well. So that's when a data point is way off your line of best fit and noticing that. Then moving on lastly to probability and looking at independent events. So I would personally say that this is going to be related to a tree diagram or counters in a bag type questions, where you've got to combine certain independent events. So basically, rather having one bag, you've got two bags, or spinners and things like that. So working with those, and again, that could easily be linked with two-way tables. It could also be linked with tree diagrams as well. And before we get started on some example questions, just a little reminder, as always, that you can access these question papers that I'm going through by clicking on the link in the description. So looking at question 1, it says the table shows the number of desktop computers and laptops in 50 households. And question A says how many households have 2 laptops. So what we want to do on this two-way table is first of all find 2 laptops, which is this column here, and we want to be adding those numbers up. So I've got 1 plus 8 plus 5 plus 0, which gives me an answer of 14. It then says how many households have more laptops than desktops. So again, if I just kind of delete that highlight just so I can do this, and then what I would then want to do is highlight the ones where the laptop number is bigger than the desktop one. So obviously I can discount these middle ones because that's where they are the same. And what I'm looking for is I'm looking for these numbers here. So from this, what I've got is I've got 5 plus 1 plus 3 plus 2 plus 8 plus 1. And so if I add all of those up, I get 9 plus 10 plus 1, which is 20. Then moving on to question 2, it says the table shows information about 80 shirts in a shop, and the first part says how many shirts are white slim. So white slim is here, so that's going to be 11. It then says what fraction of the 80 shirts are purple classic. Give your answer in its simplest form. So purple classic is here, so it's going to be 10 over 80, which is 1/8 when simplified. It then says how many of the shirts are tailored. So what I'm doing here is I'm looking for the total of this column here, and that's going to be 6 plus 5 plus 3, which is 14. It then says how many of the blue shirts are regular, or slim or regular. So looking at blue shirts, how many are slim and regular? Well, it's going to be 8 plus 9, which is 17. Then moving on to question 3, so move on to our next topic. It says that here is some information about the ages of people at a concert. And what we need to do is we need to draw a histogram to represent the information. So I'll just zoom out slightly. So here what we need to do is first of all find the class width. Now to work out the class width, that's basically the upper bound take away the lower bound. So it's going to be 5, 10, 15 and 30. And then once I've worked out the class width, I then need to work out the frequency density. Now frequency density is the frequency divided by the class width. So all I'm doing is basically dividing these two numbers up. So 8 divided by 5 is going to be equal to 1.6. Next one is 2.4, next one is 2, and the next one is 39 divided by 30, which is 1.3. So then what I then need to do is I need to then plot this along the x-axis and these values along the vertical axes. Now again, you should be using a ruler, but obviously I'm going to just kind of save time and not do that, but you should. So noticing that each little one of these little squares is going to represent 0.1 is going to be represented by 2 little squares. So 1.6 is going to be 2 squares above 1.5. So it's between 10 and 15 is going to be there and there. So quite a thin box there. And again, should be using a ruler. And then the next one is from 15 to 25, and that's at 2.4. So 2.4 is just 2 less from the top there. Like so. And then the next one is from 25 to 40, and that's to 2. Let's just use different color. So that one's nice and easy to find there. That goes up to 40. And then the last one from 40 to 70 is at 1.3. So that's going to be 4 squares below 1.5, which is there and to there, like so. And your histogram should look a little bit like that in terms of its shape, but there we go. Then moving on to question 4, it says the histogram shows information about the time some students revised for a test. The first bar represents students who revised for less than 10 minutes. Estimate the number of students who revised for less than 45 minutes. So first things first, what we need to do is recognize that we need to work out the frequencies. Now, frequency density is the frequency divided by the class width. So to work out the frequency of 1, that's going to be 0.8. So from this, that the frequency equals the frequency density times the class width. So for number 1, that's going to be the frequency density, which is 0.8, times 10, which is 8. So there are 8 students in that first block. We've then got to work out the frequency for the second one, so number 2, and we've got that's going to be it's going to be 1.6 times 20, and that's going to give me an answer of 32. Let's just write that. For number 3, that's going to be 2.2 times 10, which is 22. And then for the next block, that's going to be 2 times 20, which equals 40. Then obviously I don't need to work out the rest because the question is asking me to estimate the number of people that are 45 minutes. So what I'm wanting is this here. Now in this fourth block, there are 40 people. Now what I want to do here is work out how many people there are in each of these little slithers, these little vertical slithers. So the class width has got a width of 20. So if I do 40 divided by 20, that equals 2. So every little one of these little squares represents 2 people. Now going up to this space here, which is what I'm wanting to know, now in that little space there, which has got a width of 5, then that's going to be 5 times 2. So there are 10 people in this little slither. So then to work out how many people in total are over here, I need to add these 3 other bars. So the estimation is going to be 10 plus 22 plus 32 plus 8. So that then gives me 40. That gives me 32, which gives me a total of 72. Then looking at question 5, it says that the histogram shows the ages and years of members of a chess club. There are 22 members with ages in the range of 40 to 65, and work out the number of members with ages in the range of 25 to 40. So as you can see here, that the frequency density column is not labeled. So what I need to do is I need to find that first. So here, using this information, we know that if I just label this block as number 4, so we know that the frequency density for number 4, well, it's 40 to 65, so that's the class width. The frequency is 22, and what we need to do in the class width is 25, and we want to know what the frequency density is. So if I divide 22 by 25, so 22 divided by 25, and that gives me an answer of 0.88. So from this, what we could then need to do then is that the height of this bar is 0.88. So from this, what we can then do is work out what the labeling of the frequency density is going to be. So here we've got 11 bars equals 0.8. So that means that 1 bar is going to be, rather awkwardly, 0.88 divided by 11, so that equals 0.08. So one little box equals 0.08. Now what we're then wanting is to work out the area, the frequency of this block here. This is what we're wanting. Now the area of that block is, if we count how many sort of squares it goes up, so that goes up by 5, 10, 15, 20, 25, 30. So it's going to be 30 times 0.08, which is 2.4. So this is the frequency density for that third block, and then we need to multiply that by the class width, and the class width for that is 15. So if we multiply that by 15, so 2.4 times 15 gives us 36. So 2.4 times 15 gives us 36. Then looking at question 6, it says, in a survey, queuing times at a supermarket checkout were recorded. One morning, samples of 50 students, customers, were taken at supermarkets A, B, C and D. The box plots represent the results. So the question says, on average, which supermarket had the lowest queuing time? So what you want to look at here is you're comparing the median times. So on average, which one has the smallest waiting time? And that is going to be C, and the reason for that is because it has the smallest median time. And again, you could quote it as being 4 minutes. Then question then says that at which supermarket were queuing times more consistent? So you're looking for which one has the smallest interquartile range, which is otherwise the smallest box, and that's going to be option B. And the reason for that is because it has the smallest IQR, in other words, the smallest box. So moving on to question 7, it says, here is some information about the length of times cars stayed in a car park. And we need to draw a box plot to show the information. Now, when you're plotting a box plot or box and whisker diagram, you need 5 bits of information. You need the shortest time, the longest time, the lower quartile, the median, and the upper quartile. Now, one thing you should notice here that we haven't been given the upper quartile, so that's what we need to work out first. Now, to work out the upper quartile, that's going to be the lower quartile plus the interquartile range. So here the lower quartile is 2, the interquartile range is 3, giving me an upper quartile value of 5 hours. So from this I can then work out where my vertical lines are going to be. Now the width of the box and whisker diagram is entirely up to you. You can either do small or narrow, but as long as it's consistent, it's all good. So the shortest time is 30 minutes, which is 0.5 hours. So that's going to be there. So let's just write 0.5 hours. The longest time is 12, so that's going to go there. The lower quartile is 2. The median time is 4. And the upper quartile is 5. So then all I then need to do is turn this into, and again I should be using a ruler. I don't think you may lose marks if you didn't do it with a ruler, but again on the computer it's a bit difficult. And there is our completed box and whisker diagram. Question 8 then says that girls and boys are timed in a race. The box plot shows information about times for the girls, and it says that 25% of the boys take 12 seconds or less. The interquartile range for the boys is the same as the girls, and the ratio of the median times for the girls to the boys is 8 to 7. And the question is asking us to complete the box plot for the boys on the grid below. The times for the fastest and lowest times have been plotted for us. So looking at this then, this statement here, 25%, basically tells me that the lower quartile is 12. Then the interquartile range, which is the size of the box, is going to be the same. So looking at this, it's going to be 13 and 17. So the interquartile range is 4. So that's the length of the box. And then the ratio for the median time for the girls to the boys is 8 to 7. So if I just write down girls and boys, and the ratio is 8 to 7, then from this, well, we know that the median for the girls is 16. Let's just use that different color. And as you can see, comparing this, that means then that the median for the boys is going to be 14. So the median is 14 for the boys. So from this, I can then plot my information. So the lower quartile is 12, so I can plot that line there. I know that the median is 14, and I also know that the length of the box should be 4. So adding 4 from 12 goes to 16. And so what I'm then doing is joining these up. I can extend those lines. I'm sure they wouldn't mind, like so. And there is my completed element. So you should have this at 12, the median at 14, and the upper quartile at 16. And that should get you the full marks. So looking at question 9, it says that 48 students completed some homework. This histogram shows information about the times taken, and what this question is asking us to work out an estimate of the interquartile range. Now I would say this is probably going to be one tricky histogram question that we kind of need to look at. So first thing we need to spot is what positions are the interquartile values going to be at. So we've got 48 students. So if we divide that by 4, then the lower quartile is going to be the 12th student, and the upper quartile is going to be the 36th student. So these are the frequencies that I need to find. So I need to find where exactly, what time was the 12th student at school spent his homework doing, and how long did the 36th student spend on their homework. So the next thing I then need to do is then work out the frequencies for each bar. So in terms of the frequencies, now remember that the frequency is equal to the frequency density times the class width. So this bar here has got a frequency density of 1.6. So this bar is going to be 1.6 times 5, which is 8. This bar here is going to be 10 times 0.8, which is 8. This bar here is going to be 10 times 1.2, which is 12. And this bar here is going to be 20 times 1, so that there is 20. So for this, to find the 12th student, I need to borrow 4 from this second bar. So what I'm looking at is 4. So then here, the lower quartile equals 10. Don't know why I've written 12, so let's change that for a 10. Now to find the upper quartile, that's going to be the 36th student. So I've got 8 plus 8, which is 16, plus 12, which is 28. And then I need to borrow another 8 students from this block here. Now from this block, as you can see, I've got 20 students and 20 boxes. So here, in terms of going across, so each student, so one student equals one box column. So I need to borrow, again, I need to borrow 8 students. So I'm picking 1, 2, 3, 4, 5, 6, 7, 8. And if I draw a line going down, that works out to be roughly around about 33. So then from, oh, no, actually, no, it's not. It's going to be half in between those two. So I would say it's going to be 32, let's say. So the upper quartile is at 32. So then the interquartile range then is going to be 32, take away 10, which is going to give me an answer of 22. Now I would say you could say 33, in which then you'll have an interquartile range of 23. But I would say any of those should get you full marks, and again, it may be worth looking at the mark scheme in the document attached to see if that is the case. Then moving on to question 10, it says the scatter graph shows the age and price of 18 cars. The cars are all the same make and model. Use a line of best fit to estimate the price of a 6-year-old car. So again, what we need to do here is get our ruler, and what again, setting the parameters of a line of best fit is you want to try and have the same number of points above the line as below, and just try and go as close as you can with those. So I'm going to say my line of best fit looks like that. So we're going to use the line of best fit to estimate the price of a 6-year-old car. So from this, I'm going to go from 6, and I make out that to be roughly 3,400. And again, you can check the mark scheme to see whether your answer from your diagram and your drawing of line of best fit will give you those 2 marks. I also would recommend that you do, well, you'll get 1 mark for drawing line of best fit and then 1 mark for using your line of best fit. So make sure you are using those dotted lines for at 6. Then for question 11, it says that Julia goes for the same run every day. After each run, she records her time and measures her pulse. The scatter graph shows her results for 8 days. A line of best fit has been drawn. And the question saying, what type of correlation does this graph show? Now, because the points are very, very close to the line of best fit, I'm going to go on a limb and say that this is strong negative. If the points were further away from the line of best fit, then I would say it's weak. So the closer the points are to your line of best fit gives you an indication about the strength. Now it then says that she completes the next run in 18.5 minutes. Use the line of best fit to estimate her pulse. So what we need to do here is at 18.5, which is just there. And then we then just want to scroll across. So at that point there, it's going to be 120. Then for question 12, it says, here are some scores of 10 students in 2 tests, and we want to plot this on a scatter diagram. So again, you really want to be careful with how you're plotting this, but also make sure that you're not going crazy with big, thick, chunky crosses or dots. So the first one is at 3, 6. So again, what you want to try and do is just go as close as possible. 3 is never ideal when you're using this scale, but again, you just need to try your best. So there's my first one. And we can just give it a little tick underneath. I'm not going to cross off the numbers because I may need those numbers later. So the next one is at 6, 5, and that's going to be there. The next one is at 8, 10. The next one is at 9, 11, which is about there. Next one is at 9, 10. And the next one is at 10, 5. Next one is 11, 18. Next one is at 12, 17. Next one is at 13, 20. And the last one is at 15, 14. Which is about there. So the question then says, what is the median score for test A? So what we need to do is order these numbers. Now you can see test A has already been ordered. So I've got 10. So it's going to be in between the 5th and the 6th number. So that's going to be 9.5. Then for question C, it says the data for one student on test B seems unusual. On the scatter diagram, scatter graph, put a circle around the point that represents a student and give your reason for your choice. Now, if I was to draw a line of best fit, then I would go as far and say that we're probably looking around there-ish. Oh, don't know why that's gone so thick. Oh, that's disappeared. Let's do that one again. Oh, don't know why there's so many, so let's get rid of that one. There we go. So you're looking for which point is further away from our line of best fit, and I would say that that is going to be this one here, and that student is the 10-5, so it's this student here. So from this, given our reason for it, is because it's further away from the line of best fit. And that should be fine to get you the full marks for that question.